Hey, this is another video for my 30SH Pre-Cal students, and this is a continuation of lesson 4.4. We're going to just jump back to page 9 here and actually run through some definitions. I know we don't usually do that. We usually skip these definition pages, but some of these are very important terms that we kind of need to understand moving forward. So we're just going to jump up and start with the term optimization. In general, in math, optimization means, of course, finding the best or optimal solution to a problem. Specifically in quadratics, it means finding a maximum or minimum value. And that takes us to the next definition. What does it mean to minimize? Well, minimize means finding, I should say. Minimize is a verb. So finding the smallest possible value of a function, and of course we're talking about quadratic functions, and of course we're looking for then the y value or the y coordinate, whichever one you want to think about, of the vertex is a quadratic's minimum. And maximize, of course, means the same basic thing. It means finding the largest possible value of a function. And just like in the above, the y coordinate of the vertex, that's an f of the vertex, is the maximum of a quadratic. And make sure you understand that you can only find or you can only minimize a quadratic if, oh sorry, I'm off the screen. You can only minimize a quadratic function if it's, oriented this way, if it opens downward, and you can only other way around. Let me do that again. You can only minimize if it's oriented that way and it's opening up, and you can only maximize it if it's opening down, right? This quadratic has a minimum, this quadratic has a maximum. So it kind of depends what kind of quadratic you're looking at. The discriminant is the expression b squared minus 4ac located under the radical, the square root, of the quadratic formula. And it's used to determine the nature of a quadratic's roots. Okay, and that takes us to what real roots means. And real roots are, of course, the x-intercepts of a quadratic equation. Another way you could say this is, or the solutions of a quadratic equation that are real numbers. And of course you should remember from grade 9 that real numbers, sorry, I'm off the screen again, real numbers are numbers that actually exist on a number line. So give you a sec to catch up to me. Feel free to pause if I'm writing too fast. And the nature of the roots means it is basically whether or not the roots are real, rational, and whether there is 0, 1, or 2 roots. And what we mean by that is, keep in mind a parabola can cross the x-axis twice, having 2 roots. A parabola can just have its vertex right on the x-axis, which means it would have 1 root. And of course, a parabola can miss the x-axis completely, in which case it would have no roots. So there's our definitions to get us started with. Everybody turn to now, jump to page 12, and let's talk about the thing we just defined, the discriminant. So what do we mean by discriminant? Well, when using the quadratic formula, the discriminant is the expression b squared minus 4ac. It's called the discriminant and enables you to find out how many real number solutions a quadratic equation has without actually solving the equation, or you don't have to even graph it. If b squared minus 4ac is greater than 0, which of course is a fancy way of saying it's positive, then the equation has 2 roots, or 2 solutions. The graph has 2 x-intercepts. And the graph could be anything like, say, this or this, where it actually has 2. I should put arrows on those little arms, right? It has anything like 2 that's supposed to be a symmetrical parabola. Sorry, I'm kind of drawing small, so it's not very good. If b squared minus 4ac is less than 0, which is, again, a fancy way of saying that it's negative, then the equation has 0 solutions and 0 x-intercepts, which means that, of course, when I graph it, it never actually touches the x-axis. So it's something like those guys. And of course, the third option is, what if b squared minus 4ac in fact exactly equals 0? Well, if that happens, there is 1 solution to a quadratic equation. If I'm graphing it, it has 1 x-intercept. And that means that what that graph would look like is it would have its vertex right on the x-axis. And that can also happen whether it's a positive a value or a negative a value. Okay, so for each of these following examples, calculate the discriminant and state the nature of the roots. And by the way, the discriminant? Okay, fine. I call it the discriminant, whether I'm using it as a verb or a noun. But calculate the discriminant and state the nature of the roots. Okay, so b squared minus 4ac for this guy would be 3 squared, which is 9, minus 4 times 1 times negative 7. And 4 times 7 is 28, and it's a negative times a negative, so that's basically 9 plus 28, which is 37. So that would mean that it has, therefore, 2, and I'll say real roots. And example 2 is 3x squared equals negative 2x minus 1. Okay, this one's messing with you. You actually have to start by rearranging this to make it 3x squared plus 2x plus 1 is equal to 0, so that your b and c numbers are actually 2 and 1, not negative 2 and negative 1. So maybe we should write that down. So a is 3, b is 2, and c is 1. You can't use the discriminant. In fact, you can't use the quadratic formula at all unless you are in ax squared plus bx plus c form. So b squared minus 4ac is equal to 4 minus 4 times 3 times 1. And 4 minus 12 is negative 8, therefore no real roots. This quadratic would not cross the x-intercept. Note, if b squared minus 4ac is greater than 0, like it was in the above example 1, and it's a non-perfect square, 37 is definitely a non-perfect square, the equation has two real but irrational roots. Notice that if b squared minus 4ac is less than 0, then the equation has no real number roots, but the roots are, and the word for this is either complex or imaginary. Sorry, I'm off the screen there. Imaginary. Right? Because you'd end up having to square root a negative number, and you can't do that in real numbers. Okay, next. What do I do with this guy? Well, let's see. B squared minus 4ac. So I'm going to actually start by multiplying this entire equation by 4. So if I do that, I get 4x squared minus 12x plus 9 equals 0. So my a is 4, my b is negative 12, and my c is 9. So b squared minus 4ac is going to be 144 minus 4 times a is 4 times c is 9. And 144 minus 144, 4 4s is 16, 16 9s is 144. So I actually get a 0, and therefore that means I have one real root. And another way to think about what this answer is saying is that this answer is saying that the vertex on this parabola would actually be on the x-axis. And it says, note, if b squared minus 4ac is equal to 0, then the equation has one real numbered root. Okay, next, example 4. X squared is equal to 4. Well, I have to rewrite that in standard form, which is still x squared minus 4 is equal to 0, which means that a is 1, b is 0, and c is negative 4. So b squared minus 4ac, let me write it down this time. Plugging in my numbers, well, b is 0, so I get 0 squared minus 4 times 1, a is 1, and c is negative 4, which is 16, and 16 is positive, so therefore I have two real roots. But what happens here is that the real roots, if b squared minus 4ac is less than 0 and you get a perfect square, which is what 16 is, then the equation has two real roots that are opposite numbers. In fact, you can kind of tell that in this case, if I have x squared minus 4 is equal to 0, I'm going to get x squared is equal to 4, which means I'm going to get x is equal to plus or minus 2. So I have two roots, x is 2 and x is, negative 2, which are opposite numbers. Cool. So that's the nature of roots, and that's what we use the discriminant to help us figure out. Let's do some examples. These are kind of fun problems. I like these. So the first one says, for what values of m are, for what values of, for what values of k, I'm looking at example 6, we're on example 5. My bad. Got this paper on the wrong part of the screen. There we go, example 5. Find the values of k so that the following has real and equal roots. And by equal, we mean kind of, I should say, equal absolute values. Or another way to say it is equal but opposite. Kind of like the last one I just looked at where it was plus or minus 2. So equal but opposite. So equal but absolute value. So basically, I want to be able to see what happens. So I need b squared minus 4ac to equal 0. So let's say that first. I need b squared minus 4ac to equal 0. And let's see what that is. So b squared is, b is k plus 6. So I have k plus 6 squared minus 4 times a is 1 and c is 4. That has to equal 0. So I'm going to expand that. K plus 6 all squared is k squared plus 12k plus 36. And 4 times 4 is 16, so minus 16 is equal to 0. So I need k squared plus 12k plus 20 to equal 0. And I'm going to factor that. So let's see what that factors to. That's going to be k. What two numbers times to make 20 add to make 12? Well, that's k plus 10, and k plus 2 is equal to 0. So k is equal to negative 10, and k is equal to negative 2. All right, so that means that, let's try our answers. If k is equal to negative 10, what happens? Well, then I'm going to have negative 10 plus 6, so I'm going to have x squared minus 4x plus 4 is equal to 0. And in that case, I get x minus 2 squared is equal to 0. So that means x would equal 2. So that's the value. So that's the first k. So that one works. I get equal roots there. So k is equal to 2. And what if, x is equal to 2. If k was negative 2, let's check that answer out. Well, if k is negative 2, then I get x squared plus 4x plus 4. And that works as well, because that would be x plus 4 is equal to, x plus 2, I should say, squared is equal to 0. And then therefore x is negative 2 is my x-intercept. And once again, x is negative 2 for the second example is my x-intercept. So there we go. Example 6. For what values of m will the following equation have real but unequal roots? Okay, so first of all, we're going to say that that means that a is 1, b is 8, and c is, well, I don't know what number it is, but I know that it's negative m, right? Because that negative belongs to m. So b squared minus 4ac, to have real but unequal roots, I have to be greater than 0, and I can't be a perfect square. So let's see. So let's see how that's going to look. So b squared, that'd be 8 squared minus 4 times 1 times negative m, has to be greater than 0. So let's see. So that's going to be 64 plus 4m has to be greater than 0. Do you remember how to solve inequalities from grade 9? We're going to minus 64 from both sides. That doesn't change the inequality. And we're going to divide both sides of that inequality by 4, which also doesn't change the inequality. And so m has to be greater than 16. So that means, therefore, any value for m greater than negative 16 will give 2 real roots. Okay, next, example 7. Given the following equation, what values of k would the roots not be real? Okay, so once again, a is 2, b is the value I don't know, which is called k, and c is 2. So b squared minus 4ac to have no real roots has to be less than 0. So that's going to be k squared minus 4 times 2 times 2 has to be less than 0. So that means that k squared has to be minus 4 times 4 is 16, has to be less than 0. So k squared has to be less than 16. Okay, now when I square root both sides of that, here's what I have to consider. I have to consider the plus or minus thing. And of course, if it's plus or minus, that's going to, if it's minus, it flips the sign. So let's think about that. K has to be less than 16. K squared has to be less than 16. So let's explore that for a sec. If k is 4, then k squared is equal to 16. But for k to be less than 16, well, hang on a sec. Think about this through. Let's just assume that it wasn't equal. If k squared was equal to 16, then k would equal plus or minus 4. So think about this. My answer then is going to be, well, then k has to be greater than negative 4, but less than 4. Think about this. Why does k have to be greater than negative 4? Like, why couldn't k be negative 10? Well, because negative 10, when I squared it, would end up being positive 100, right? Because positive takes away, the square takes away the negativity of k. So that means that it can't be just anything less than 4. It has to stop at negative 4. So there's my solution. K would have to be any number between negative 4 and 4. And if you still have to kind of think about why that is, you could even draw yourself a little number line if you wanted to. And on your number line, think about it. If you have 4 here and -4 there, any number between here and here, when you square it, is going to be smaller than 16. But any number that's past it that way would not exist. So these arrows here would represent the numbers that you can't have. These would not be the solutions, and the actual solutions would be any of the numbers between here and here. So solution would be in here, and anything that way or that way would not be a solution. So that's my answer for K. Cool. So those are fun problems. They're fun to think about. All right. Thanks for watching, and you've got some homework to work on.